I'm the lab manager here at Aspen Mountain Medical Center. I want to thank you for participating in our health fair, and we're making this video to show you exactly what happens to your blood after we've taken your blood sample, because most people don't get to see what happens in the laboratory. The first thing that happens is we take your blood sample and we spin it down. So most of you had your blood drawn in one of these 3 tubes or all of these 3 tubes, and everybody asks me, what's the difference between the 3 tubes? Why can't I just get my blood drawn in one tube to be tested for everything? Well, there's a good reason for that, and a good reason for the different colors. Each tube has a different additive in it. The purple additive, or the purple top tube, has the additive EDTA. And what it's used for, we use it for CBC, hemoglobin A1C, we use it to do blood typing, and what the EDTA does is it keeps the sample from clotting, and it also is used to preserve the red blood cells, white blood cells, platelets, and it keeps them from clumping as well. And we use this tube as either whole blood, or we'll spin it down and use the plasma off of it, and I'll be showing you what that looks like later. The red top tube is a serum tube, meaning that we spin it down and we just use the liquid portion of the blood off of it. This tube clots, so we let this tube sit for 30 minutes before we spin it so that the blood will actually clot in it, and then we spin it down. So the liquid portion left in this tube is called serum because it doesn't have any of the clotting factors or proteins in it. Okay. And this one's used for chemistry panels, iron studies. We can use it for thyroid, PSA, things like that. Also known as SST. This tube is a plasma separator tube. We call this one PST to abbreviate. We're always abbreviating things in the lab. And it has an additive in it called lithium heparin. And what it's used for is it is an anticoagulant. It keeps this tube from clotting. So the SST tube clots. This tube does not clot. We spin it right away. And we use this a lot to run chemistries or things that we're in a hurry to run. If the doctor needs a result quickly for a chemistry or something, we'll put it in a PST tube. So the liquid portion that we test out of this tube is called plasma because it doesn't clot. So it still has clotting proteins and clotting factors in it. And so I'll show you what those tubes look like after we spin them down. Another question people ask me is after I draw their blood, they'll see their red blood sitting on top of these white little, it looks like gel, or people will call them goobers or whatever, in there, and their first question is, oh, did that come out of me? No, it didn't. It was already in the tube. And so when we spin it, it comes up and separates the red blood cells from the plasma in this tube and from the serum in this tube. So you can get a good look at it. So that liquid portion is what we test. We don't test these red blood cells at all. And then of course, we will test the purple top tube as whole blood and see how it's not clotted. It's still just like it was when it came out of your body. And then we'll spin it down and we'll test this plasma liquid part off of it for certain tests. Okay? testing. And I know you probably remember in school poking your finger and doing your blood testing on a little card that had circles, and you would add a little reagent and add your blood to it, and if it clotted, it would show what type you were. Well, we test by the same principle in these cards, these MTS microtubule cards. And so what we're testing for, let me get these closer to the camera so you can see real good. What we're testing for is antigens to A, B, and then D. And then of course we have our control, and then we're going to test for antibodies to A and B. In the lab we call these forward and reverse typing. So whatever you get in these two should be opposite in these two. And if your test result is positive in A, you're type A. If it's positive in B, you're type B. If it's positive in A and B, you're type AB. And if it's negative in A and B, you're type O. And then you should be reverse in these two. And then of course your control should be negative. And then if you're positive in D, which is your RH factor, you're RH positive. And if you're negative in D, then you're RH negative. So I can show you a couple examples of some typing we have done on some patients so you can see. This particular patient is O positive. So of course, and this card is backwards because the patient's name's on this side. So this is the forward typing, and you can see a negative reaction in A and B, and then the reverse positive reaction for antibodies to A and B over here. And then of course a positive for the D, so O positive. And I've also got an A positive person, and you can see they're positive in the A, negative in the B, and then over here in the A, they're negative, but they're positive in the B, meaning that they have an anti-A, or anti-B, sorry about that. Most of the chemistries and CBC, A1C, thyroid, PSA, iron studies, CRP, those tests are done on analyzers, which is kind of hard to show you exactly what the machines do with those analyzers with your samples running, because they have covers on them that need to be closed while they're running. So I did put some samples on there, and I can kind of show you parts that you can see, and I have some of those that'll be in this video later. But those covers need to be down because these tests are run at certain wavelengths, and so the amount of light that comes into the machine needs to be controlled for accurate results. So I will just kind of show you what I can show you on those. Let me talk about our CBC machine. Our CBC machine is a 5-part differential machine, meaning that it actually separates out the 5 different white blood cells and does a differential on them automated. So it actually tests for the actual number of neutrophils, lymphocytes, basophils, eosinophils, and monocytes, and gives you a nice differential of those. It tests for red blood cells, white blood cells, platelets, and then gives you your indices on red blood cells and on your platelets as well, and hemoglobin and hematocrit. So that's the basic parts of your CBC, and our machine tests for all of those directly, and it's very quick. Just takes a couple minutes to get those results. And it does this by sending your blood sample through a little aperture, and then it counts as it's going through the aperture, and and then it enumerates the cells and separates them based on lysing the actual nucleus of the cell and checking the density of the nucleus of the cells. So that's how it counts them. It's really quick and fast and doesn't take long. Chemistry analyzer is kind of interesting. A lot of labs have a chemistry analyzer, and then they have an analyzer that would do their TSH and PSA separately, so two different analyzers. Ours is called an integrated chemistry, which is a new thing that they're doing in lab, where they're putting both of those two machines into one analyzer. So our machine actually does both of those. So a CMP lipid, TSH, PSA, CRP, iron studies, those are all done on this chemistry analyzer made by a company, Siemens. It's a very good analyzer. The company's been around a long time making chemistry analyzers. And the way they test each different test, a lot of them are done by color changes. So the darker the color, the higher your result is. A lot of them are by turbidity, so the more turbid the sample is, the higher your result is, and vice versa on those. A lot of them are read at different wavelengths of light, so it's very important to keep the covers down so all of that is accurate. Sodium, potassium, and chloride are measured by electrolytes, so difference in electroconductivity for those. And just basic different principles. The TSH and PSA are immunoassays, so those are actually tested by attracting antigens and antibodies. So different methodologies on all of those, all in one analyzer. is our last thing that we do in the lab, and A1C is done off of a simple machine that is super easy. It takes a drop of blood that we put into a little cartridge where the cartridge is mixed and the amount of A1C is measured by the wavelength of light that it's read at by a color change as well. So it's very fast. The A1C takes about 7 minutes to perform, which is super easy. It's a very accurate, well-used machine made by Siemens again.